Hello, welcome to lesson 8.3, trig ratios, find angles. So the first thing we're going to do is cross out right here. That's a typo. It should say find missing angles. And that's what we're doing today. We're going to be finding the missing angles in right triangles using trigonometry. So just to review, we're going to be given a theta, so you can actually draw that in too, of a triangle. So we're going to label the hypotenuse. The opposite is across from theta, and adjacent is next to theta. And we're going to be using the functions here, sine, cosine, tangent. SOHCAHTOA reminds us of what those ratios are. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's get into example number 1. So also grab your calculator, we're going to need it again. And also make sure it's in degrees, not radians, by testing it out with sine of 30 and getting 0.5. All right, so number 1. First step, we're always going to still label H, O, and A. So our hypotenuse is right here across from our right angle. This theta, this question mark is theta, so we can write that in. So opposite that would be, right, across from that. So this one is O. And then next to it would be adjacent. So that one is A. So our second step, just like in our last lesson, what information are they giving us? They're giving us that the hypotenuse is 23 and that the opposite is 17. So we're going to underline that those two sides they're giving us. So adjacent is blank. We're not going to use A. So now which trig ratio, which function has an O and H in it? And we can look up and see that it is sine that has O and H. So we're going to write sine of theta is equal to O over H. And now we're going to plug in our information. So theta, we don't know it. We don't know what the angle is. That's what we're trying to find today. So we're going to put an X for theta. We know the opposite is 17, and we know the hypotenuse is 23. So before we found X, because we could either multiply or divide and get X by itself, but this time it's sine of X. So how do we get X by itself? We wanted to switch places with this number over here, and we do that with the inverse sine function. So we're going to write inverse sine, which is sine to the -1. And when it's inverse, that means we can switch the places. So that means X and our fraction here is going to switch places. So 17 over 23 goes where the X was, and now the X is on the other side where the fraction was. And this is what we're going to put into the calculator, because now our X is by itself. So we're going to put in inverse sine 17 over 23. So in your calculator, yours is going to look probably different than mine. So with mine, they're actually, so I'm going to hit this button here. You will probably have a button that says INV. I can't really write on here now, but it's going to say INV, which stands for inverse. Or yeah, if you need help finding it, just pause the video and I can show you. But so inverse sine, and I already forgot the fraction. So 17 over 23. So inverse sine, 17 over 23. And we hit equals. And we're going to round this to the nearest degree this time, not the nearest tenth, but to the nearest whole number. So this is just 48. So 48 degrees is our answer. And that's it. So go ahead and pause the video. Try number 2 on your own. All right, so let's go ahead and label. So we have our hypotenuse. We have our opposites, and we have our adjacent. So they're giving us H and O, and I'm going to use sine based on that. So sine of theta is O over H. We're going to fill in the theta is unknown, and this whole lesson, the theta is going to be unknown. We're always going to be finding angles in this lesson. So I'm always going to put X for theta. O is 15, and H is 53. So now I want X by itself, so I'm going to use inverse sine. So sine -1, and I'm going to put the fraction in place of the X and the X in place of the fraction. I'm going to plug this into the calculator. Inverse sine 15 over 53. So inverse sine 15 over 53. And when I round to the nearest whole number, that is 16. So my answer here is 16 degrees. All right, so let's go on to 3. So, and actually these are all pretty much the same. So if you want to just try the rest of these on your own, you can, but I'm going to still do 3 and 5 as examples because now you'll see in a second, we're going to be using just a different function. So this is hypotenuse, across here is opposite, next to it is adjacent. So see how this one, they're giving us h and a. So I'm going to be using a different function. That's all. I'm going to be using cosine. And how do we know it's cosine? Because we look up here, which one has a and h in it? That's the c, that's cosine. So I'm going to write cosine theta is equal to a over h, adjacent over hypotenuse. I'm going to put in x for theta. A is 31 and h is 32. Now to get x by itself, I use inverse cosine, so I switch places. And now x is by itself, so I'm going to put in inverse cosine 31 over 32. I hit equals, and this is 14. So it is 14 degrees. Is that the same as the last one? No, 16. Very close. See how they're both kind of small. So you know you should be on the right track here. Yeah, so go ahead and try number 4. See what you get. All right, so this is going to be H, O, A. They're giving us A and H, so we're going to be using cosine again. Theta is X, A is 4, H is 7, and I'm going to use inverse to get X by itself. Okay, once I get X by itself, this is what I'm putting in the calculator. Inverse cosine 4 over 7. Inverse cosine 4 divided by 7, and this is 55 degrees. Okay, I've got one more example, but feel free to pause now. Here, actually, sorry, let me go back here in case I went too fast. All right. So now try number 5, or you can follow along with me. So our last example, though, is H, O, and A. Just one more time. I know I've done this a lot of times, but just the H is always across from the right angle. The O is across from the theta, the angle, and A is next to the angle. Okay, so H, O, and A. Once I do that, I have A and O given to me. Those are the only two sides that have a number there, the only ones that have some sort of information. So because of that, because see how H is blank, I can't use hypotenuse. I have to use the function that has A and O in it, which would be, right, tangent. Tangent has O and A. So I'm going to write tangent of theta is equal to O over A. Then I fill in. Theta, in this case, is going to be x. If we're trying to find the angle, that's unknown. So we're putting an x there. O is 23 and A is 38. I want to get x by itself, so that's why I have to use inverse tangent so I can switch places, right? And now x is by itself, and now I can put this into the calculator. So inverse tangent, 23 over 38. So that is 31, rounded to the nearest whole number. So 31 degrees. And now you're going to pause the video, try this last one on your own. All right, so hopefully you've labeled H, O, and A. Remember, A should be, the last one should be right next to the angle. They're giving us O and A, so we're going to be using tangent, which is O over A. We don't know what the angle is, but we know O is 41 and A is 15. So we're going to do inverse tangent 41 over 15 to get our answer. So 41 over 15. And that rounds to 70. right? The 0.9 makes it go up to 70 degrees. All right, so if you have any questions, how to use calculator, how to do the steps, anything like that, please let me know. Otherwise, I will see you in the next unit. Bye.